Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Today we'll continue with our discussion of limits by considering limit laws and how we go about computing limits. If there's a function f of x that has a limit as x goes to a, and that limit is L, and if as x goes to a, the limit of g of x goes to m, then we can manipulate f of x and g of x and consider limits of these manipulated quantities. For example, f of x plus g of x will go to the sum L plus m as x goes to a. The product f of x times g of x goes to L times m, and the quotient f of x divided by g of x goes to L divided by m if m is not 0. If we want to find the limit, actually calculate the limit, well, the first thing to do, the easiest thing to do, is to try plugging in. In the example we have here, the limit as x goes to 5 of 2x squared minus 3x plus 4, we can just plug x equal 5 in and we can find the limit. In other cases, for example, when a denominator is equal to 0, things aren't so simple. And we have three methods or tricks that we can apply in order to try to find the limits of such quantities. For example, in the case of limit as x goes to 3 of x squared minus 9 over x minus 3, we can factor the numerator into x plus 3 times x minus 3. The x minus 3's cancel out, and then we can revert to the first method by plugging in x equal 3. Another technique is to rationalize either a numerator or a denominator. In the example that we have here, we have the limit as x goes to 0 of the square root of x squared plus 9 minus 3 over x squared. If we plug in, once again, we would get 0 divided by 0. And so we need to do something more strategic. In this case, we multiply by the conjugate of the numerator. That way we get the square roots to go away, and we can then analyze the expression and find the limit. A third technique we can do is to try to understand what the function looks like and to see if we can squeeze the result into a bound, a limit that we can understand. So in this case, we have the limit as x goes to 0 of x squared times sine of 1 over x. And we can note that since the value of sine always lies between minus 1 and 1, that the quantity x squared times sine of 1 over x always lies between minus x squared and plus x squared. And as x goes to 0, minus x squared goes to 0, plus x squared goes to 0, and x squared sine of 1 over x must lie in the middle, and so it must be squozen to become 0. Let's take a moment for some math culture. While giving a lecture on the mechanics of momentum and kinetic energy transfer, the physics professor noticed a student busily snoozing in the fourth row of the auditorium. He turned to a young lady sitting in the first row and asked her what the result of a collision between two particles with given masses, velocities, and trajectories would be. After a few seconds of thinking and calculating, the young lady came up with the correct answer. The professor then awoke the sleeping student and said, "You, same question." The student, a bit stunned and bleary-eyed, looked around and replied, "Same answer." Thank you for joining us today. Have a great day, and may the power of math be with you.